Welcome to this video on the multiplication rule for independent events. After watching this video, you will be able to define the terms dependent and independent as they relate to probability, identify events or trials as dependent or independent, state the multiplication rule for independent events, apply the multiplication rule for independent events, and lastly, explain the difference between independent events and mutually exclusive events. Independent versus dependent events. Two events A and B are independent if the occurrence of event A does not change the probability of event B. Trials done with replacement are considered independent. Two events A and B are dependent if the occurrence of event A changes the probability of event B. Trials done without replacement are considered dependent. Dependent or independent. Suppose you roll a six-sided die and it lands on a 6. Does this outcome affect the probability of getting a 6 on the next roll? Pause this video, write down your guess, and then unpause the video to check your answer. The answer is that these events are independent, so the first roll does not affect the probability of the second roll. Despite the hot hand fallacy, which is a cognitive bias that suggests that good luck will continue to happen, or the gambler's fallacy, which suggests that outcomes must balance out in the short term, these two rolls of the die are independent. If you roll a 6, the next time you roll the die, you are neither more nor less likely to roll a 6 than you were the first time. What about a coin toss? If you flip a coin and it lands on heads, does this change the probability of the coin landing on heads on the next coin flip? Pause the video, write down your answer, and then unpause it to check your answer. No, these events are independent. If the coin lands on heads, the next time you're neither more nor less likely to get heads than you were the first time. Dependent or independent. Suppose you pick out a card from a deck of cards and it is the Ace of Spades. Does this event change the probability associated with the next card you draw from the deck? Pause this video, write down your answer, and then unpause it to see if you are correct. With or without replacement. If you answered yes to this question, you are correct. However, if you answered no, you are also correct. To answer properly, you must first know whether the first card you drew from the deck was replaced back into the deck before you drew the second card. When playing cards, it is unlikely that a person would actually replace the first card and shuffle it back into the deck before the second card is drawn. If the second card is drawn before the first card was returned to the deck, i.e., things were done without replacement, then we say that the two events are dependent. With replacement. If, however, you replace the first card and shuffle it back into the deck before drawing a second card, then we say the two events are independent. Independent or dependent. Suppose there are 10 marbles in a jar with colors as follows: 1 white marble, 4 blue marbles, 2 purple marbles, and 3 yellow marbles. If you pick a blue marble from the jar, is the probability of picking a second blue marble dependent or independent on the first event? Once again, it depends on whether you replace the first blue marble you drew from the jar before you draw a second marble. If you replace the first blue marble before drawing a second one, i.e. with replacement, then the two events are independent. If you leave the first blue marble out of the jar without replacement, then the two events are dependent. The multiplication rule for independent events. The multiplication rule for independent events states that the probability of event A happening and then event B happening is as follows. The probability of A and B is equal to the probability of A times the probability of B. This rule can be expanded to encompass 3 events. So the probability of A and B and C is equal to the probability of event A times the probability of event B times the probability of event C. We can also generalize this rule to include any number of events. Let's apply this rule to some of the previous examples we just discussed. Example 1, rolling a die. What is the probability of rolling a 1 and then rolling a 6? First, we have to answer the question, are these two die rolls independent? They are, as we said previously, so we can apply the multiplication rule for independent events. the probability of A and B is equal to the probability of A times the probability of B. Putting that into the context of this particular problem, we say that the probability of getting a 1 and then a 6 is equal to the probability of rolling a 1 times the probability of rolling a 6. In our basic probability video, we learned how to calculate the probability of die rolls. So we know that the probability of rolling a 1 is 1 over 6, and the probability of rolling a 6 is also 1 over 6. So as we calculate our probabilities, we have 1 6 times 1 6. This is 1 over 36, which is about 3%. Example 2, rolling a die. What is the probability of rolling 3 ones in a row? Pause this video, see if you can calculate the probability, and then unpause it to check your answer. First, we have to answer the question, are these die rolls independent? They are, so we can apply the multiplication rule for independent events. Remember, it can be generalized for any number of events. In this case, we have 3 events, so we say the probability of A and B and C is equal to the probability of A times the probability of B times the probability of C. Putting that into the context of this problem, we see that the probability of rolling a 1 and then another 1 and then another 1 after that is the probability of rolling a 1 times the probability of rolling a 1 times the probability of rolling a 1. So remember, the probability of rolling a 1 is 1 over 6. So we multiply 1 6 times itself 3 times, and we get 1 over 216, which is 0.005 or 0.5%. Can you extend this pattern to figure out the probability of rolling 4 ones in a row? What is the probability of flipping a fair coin and getting tails twice in a row? First, we must answer the question, are the coin flips independent? They are, so we can apply the multiplication rule for independent events. The multiplication rule for independent events states that the probability of event A and then B happening is equal to the probability of event A happening times the probability of event B happening. Putting that into the context of this problem, we find the probability of getting tails and then tails again is equal to the probability of getting tails times the probability of getting tails. For a fair coin, the probability of getting tails is 1/2. Putting that value into the equation, we find that the overall probability is 1/4, which is the same as 0.25 or 25%. Can you extend this pattern to figure out the probability of getting tails 4 times in a row? Example 4, picking a card. What is the probability of picking 2 aces in a row with replacement? There are 4 aces in a deck of cards, so the probability of picking an ace 1 time is 4 over 52. Pause the video and see if you can use this information to calculate the overall probability. Note that the phrase with replacement was used in the original question, so that means that these 2 events are independent. Therefore, we can use the multiplication rule for independent events. Remember that says that the probability of A and B is equal to the probability of A times the probability of B. Putting that into the context of this problem, the probability of getting an ace and then another ace is equal to the probability of picking an ace times the probability of picking another ace. As we said on the previous slide, the probability of getting an ace is 4 over 52, and we can reduce this fraction to 1/13. Putting that value into our equation, we have 1/13 times 1/13, which is 1 over 169. This is about 0.006 or 0.6%. Can you extend this pattern to figure out the probability of picking 4 aces in a row? Example 5, picking a marble. Suppose there are 10 marbles in a jar with the colors as follows: 1 white marble, 4 blue marbles, 2 purple marbles, and 3 yellow marbles. What is the probability of picking 2 purple marbles in a row with replacement? First, we have to ask ourselves, are these 2 events independent? The phrase with replacement was used, so the events are independent. Therefore, we can use the multiplication rule for independent events. Remember, that rule states that the probability of A and B is equal to the probability of A times the probability of B. Putting that into the context of this problem, we find that The probability of picking a purple marble and then another purple marble is equal to the probability of picking a purple marble times the probability of picking a purple marble. The probability of picking a purple marble is 2/10, which reduces to 1/5. Putting that into the equation, we find that the probability of picking 2 purple marbles in a row with replacement is 1/5 times 1/5, which is equal to 1/25. This can also be expressed as a decimal, 0.04, or a percent, 4%. Can you figure out the probability of getting 3 yellow marbles in a row with replacement? The last topic in this video is to compare the concepts of independence and mutually exclusive events. Do the terms independent and mutually exclusive mean the same thing? Pause this video, write down your answer, and then unpause it to see if you're correct. The answer is that independence and two events being mutually exclusive or disjoint are unrelated concepts. If two events are independent, that means that one event does not affect the other. For example, 2 coin flips are independent because the outcome of the first coin toss does not affect the outcome of the second. However, if two events are mutually exclusive or disjoint, that just means that they have no outcomes in common, or that they cannot occur at the same time. For example, getting heads and tails are mutually exclusive events because they cannot occur at the same time. When you flip a coin, it either lands on heads or tails. Be careful as you move forward in this section on probability that you do not confuse these two concepts. Having watched this video, you should now be able to define the terms dependent and independent as they relate to probability, identify events or trials as dependent or independent, state the multiplication rule for independent events, apply the multiplication rule for independent events, explain the difference between independent events and mutually exclusive events.